Now let's go over with the paired sample t-test. We're going to use the INO's experiment for this. So the INO collected the students' heart rate and saved them as a HR base, as a baseline heart rate. Then INO announced the pop quiz all of a sudden, then handed out the stats questions and students kept it face down. Then they reported the per scan and saved it as a HR pre. It's a pre-quiz heart rate. So notice that we have two measurements from the same individual. The two measurements are paired, but they're not independent. So this is the case we can use the paired sample t-test. For another example, suppose we conduct a survey on the political propensity of the couple. We get the measurements from wife and husband, and we'd like to know if there's any difference in their political propensity. So in this case, we have a pair of measurements from different individuals, but those measurements are not independent. So we can use a paired t-test. So in paired t-test, the point is we consider the mean difference of the two measurements, but we treat them as one sample. Because they are not independent. So the whole procedure of a paired t-test is actually the same as the one sample t-test. So to answer the research question, so the first thing is to state the hypothesis. So look at the so recall our research question. We here we expect to see the pre-quiz heart rate would increase or greater than the baseline. That's our interest, which should go with alternative hypothesis. So we can express the alternative hypothesis like here the mu pre is greater than mu base. Then the null hypothesis should go the other way, containing the equality. So and then the mu base represent the population mean heart rate at baseline, and mu pre represent the population mean heart rate at pre-test. So here we go, the SPSS. So we're using the HR base and HR pre. All right. So here, to analyze and compare means. Compare the sample t-test. Choose the HR pre on the HR base, then HR pre. Okay, if we go to option to check the confidence interval is 95%, then okay. So we've got three tables as output. Let's see what it's like. So here the table is a descriptive statistic as usual for each variable. So the baseline heart rate and pre-quiz heart rate each mean is so baseline heart rate is 72.27 and pre-quiz heart rate is 73.85. So we're going to see whether the difference between these two numbers is significantly different, or essentially we're going to see whether the pre-quiz heart rate is greater than the 72.27. And then sample size, standard deviation, standard error of the mean, the same. So you see the correlation of those two measurements. Actually, it's not surprising that those two measurements have a correlation because those came from the same individual. So, no. Then this is the result of a paired sample t-test. Then you see here the mean of different scores, standard deviation of different scores, and standard error of the mean of different scores. Now the end section, you see the t and degrees of freedom and p-value for two-tailed. Then the t statistics computed by this as usual. And degrees of freedom is 100 minus 1 is 99. As I said, the paired sample t-test is nothing more nothing more than just a one sample t-test, because we treat them those two measurements as one sample. Then we've got this p-value is obviously very small than the 0.05. So according to the decision rule, is a p-value is less than alpha, we're going to reject the null. But here, those one step to go further here, because this p-value is for two-tailed test. So to recall our hypothesis, we are testing is a one-sided alternative hypothesis. Here is greater than. So it's not appropriate to use the two-tailed p-value because the two-tailed p-value considers two possibilities such as greater than or less than. So in this case, we should divide the current p-value by 2. Because the SBASE always provides a two-tailed p-value. So it's your job to use a proper p-value depending on your alternative hypothesis. So the half of the current p-value is getting smaller. It doesn't affect our conclusion there. So we can conclude like it's significant. Okay. Now you see the confidence interval, so we can say 95% confident that the true population mean of different scores, baseline heart rate minus prerequisite heart rate, should lie somewhere between negative 2.48 and negative 0.68. Notice that this interval does not contain the zero value, which means that the true population mean of different scores, there's zero chance that the population mean of different scores could be 0. So the result is consistent. The result of a confidence interval is consistent with the result from the hypothesis testing. So this is the APA format to report, so nothing special here. We can say the paired sample t-test showed the student's heart rate significantly increased from baseline to the per-question measurement. Okay, this is the end of a paired sample t-test. Now, lastly, we move to the independent sample t-test.